Hello everyone, welcome back to my channel. So in this video we'll solve some more problems on propagation of waves in different medium. Okay, so if you are first time to my channel, please consider subscribing and hit the bell icon to get the video notifications from my channel. Right, we'll see the first question. So in the question number 1, he has given the electric field intensity. Okay, so 2 cos of omega t minus beta x ay cap, right, and he has asked you to find the h bar. Okay, so magnetic field intensity if epsilon r mu r is equal to 1. So when epsilon r mu r is equal to 1, then the medium is free space. So medium is free space medium. Okay, so when the free wave, what, so I have already told you the relationship between E bar and H bar. So if E bar is given as some E naught into cos of omega t minus beta x, suppose ay cap, then how can we write H bar? H bar can be written as E naught by eta, E naught by eta cos of omega t minus beta x minus theta n az cap. Sorry, if it is ay, right, because wave is propagating along x direction, so it will be az cap only. Okay, so when wave is propagating along plus x direction, when wave is propagating along plus x direction, so how can we find whether wave is propagating in plus x direction? Again from this, so cos of omega t minus beta x represents the wave is propagating along positive x direction. So when wave is propagating along positive x direction, so these are the relationship between E bar and H bar. Now E bar is given, right? So E bar is given for you, so E naught value is 2. Okay, and eta we have to find, right? Eta we have to find. So once you find eta and theta n, then we can write the equation for H bar. So in free space, so now we have got epsilon r is equal to mu r is equal to 1. When epsilon r mu r is equal to 1, then epsilon is equal to epsilon naught, mu is equal to mu naught, mu is equal to mu naught. Okay, so when epsilon is equal to epsilon naught and mu is equal to mu naught and alpha is equal to 0, alpha is 0 because no attenuation constant is given. Okay, so which medium satisfies all these conditions is free space medium. Okay, so in free space medium, in free space, when the medium is free space, then what is the value of intrinsic impedance? Eta naught I have told you, so eta naught is equal to 120 pi or 377 ohms. Eta naught is equal to 120 pi or to 377 ohms. So H bar is equal to E naught is 2 divided by eta naught is 120 pi. So what is theta n value again? Theta n is equal to 0. So when the medium is free space, I have told you already all the characteristics of free space medium, all the wave characteristics. When wave is propagating along free space, I have told you all the characteristics. There I have told you that theta n is equal to 0. If you have not watched that video, please watch. I am giving the link in the description. So playlist link I am giving in the description. So in that, watch the video of plane wave characteristics when wave is propagating in free space. Okay, so theta n is equal to 0. So H is equal to E naught by eta cos of omega t minus beta x, because theta n is equal to 0 az cap. Okay, so ampere per meter. So it will be 1 by 60 pi, 1 by 60 pi into cos of omega t minus beta x into az cap ampere per meter. Okay, so this is how we can find H bar if E bar is given when the medium is free space medium. Okay, so next we'll see one more problem, right? Second question. So in this question he has given A plane wave is propagating through a medium having epsilon r is equal to 8, mu r is equal to 2 and sigma is not equal to 0. And if E bar is equal to this, then what is the value of wave impedance he is asking. Okay, so when sigma is not equal to 0 and you have some values for epsilon r and mu r, okay, so what is the medium when sigma is not equal to 0? So medium is good dielectric. Yes or no? So for free space, sigma is equal to 0. For perfect dielectric, sigma is equal to 0. For good conductor, sigma is infinity. So when sigma is not equal to 0, then it is a good dielectric medium. Okay, so from the given data, so E bar is equal to 0.5 into e power minus z by 3 sine of 10 to the power of 8 t minus beta z ax cap. That is, wave is propagating in plus z direction. So wave is propagating in plus z direction. This is the first inference. Okay, so omega values. So I'll write the general form first. Okay, so E bar is equal to E naught into e power minus alpha z. Okay, sine or cos, no problem. So sine of omega t minus beta z ax cap. Okay, so comparing these two, so alpha is equal to 1 by 3. So alpha is equal to 1 by 3 Nepper per meter, and omega is equal to 10 to the power of 8 radians per second. Okay, and we have epsilon r value is 8, mu r value is 2. Okay, so when the medium is good dielectric, so what is the value of alpha? Alpha is given by sigma by 2 into root of mu by epsilon. Okay, sigma by 2 into root of mu by epsilon. So we are not given with the conductivity value, so we have to find the value of sigma. Okay, right, so what is alpha? Alpha is 1 by 3 given, so sigma value only we want to find, by 2 into root of, what is mu? Mu is mu naught into mu r, so mu naught into 2 divided by epsilon is epsilon naught into epsilon r is 8. Okay, so what is root of mu naught by epsilon naught? So it is 120 pi. So sigma by 2 into 120 pi into, so root of 1 by 4, it will become 1 by 2. So 2 ones are 2 60s are and 2 ones are 2 30s are. So sigma is equal to 1 by 90 pi. 1 by 90 pi. So if you calculate, you will get around 3.536 into 10 to the power of minus 3. Okay, Siemens per meter. Okay, or mho per meter. Anyone, you can write any unit. Okay, so we have found only conductivity. Now we have to find the value of wave impedance. So what is wave impedance formula? Root of j omega mu by sigma plus j omega epsilon. Okay, sigma by j omega epsilon. So is equal to root of j into, what is omega? Omega is 2 pi into f. Right, so omega value is, we have given with omega value directly, so omega is 10 to the power of 8 into mu value. Mu value is mu naught into mu r. Mu naught value is 4 pi into 10 to the power of minus 7. Okay, 4 pi into 10 to the power of minus 7 into mu r value is 2 divided by sigma, just we have got 3.536 into 10 to the power of minus 3 plus j into omega value is 10 to the power of 8. Epsilon is epsilon naught into epsilon r. Okay, so epsilon r value is 8, epsilon value is 8.85 into 10 to the power of minus 12. Okay, solve this in the denominator. Right, so if you solve it, so you'll get around j 251.32, so in the numerator, and in the denominator you will get 3.536 into 10 to the power of minus 3 plus j 7.083 into 10 to the power of minus 3. Okay, so 10 to the power of minus 3 is common in both terms, so send it to the numerator. So what you will get, j 251320. So I am multiplying with 10 to the power of 3 here. Okay, so denominator also, if you multiply with 10 to the power of 3, these two terms gets cancelled off. So what is left over then? 3.536 plus j 7.083. Okay, so representing both in polar form, representing these two in polar form, what you will get? So under root of 251320 angle of 90 degrees divided by, so if you represent this also in polar form, that is a square root. So how can you represent it? Square root of 3.536 whole square plus 7.083 whole square. Okay, so find this value. So this value will be around 7.92. Okay, and angle of this, so tan inverse of 7.083 divided by 3.536, so this angle will become 63.47. Okay, so 7.92 and 251,320. So if you divide these two, magnitude these two, and take under root, so you'll get a 178.17. and angle, so how can you write angle? So actually what will be the angle? Angle will be 90 degrees minus 63.47, so it will be around 26.53. so it is under root, right? So it is under root. So when angle is under root, what I have told you, a root of angle theta is equal to theta by 2, you can write. So angle of 26.53 divided by 2. So 26.53 divided by 2, so it will be around 13.27 degrees. Okay, so this will be the value of eta in ohms. Okay, so this is how we can find the intrinsic impedance of a given good dielectric medium. Okay, so just be aware of these calculations only. Okay, that is why I have taken this problem. Okay, so next we'll see one more problem on wave propagation. Okay, so he has given that the medium is lossless medium and eta is given for u with mu r, and he has asked you to find relative permittivity and equation for electric field intensity if the magnetic field intensity equation is given for you. Okay, so from the magnetic field intensity, so this will be hx cos of omega t minus z ax cap plus hy sin of omega t minus z ay cap, right? So hx value is, so hx is equal to minus 0.1 and hy is 0.5. Okay, so in the case of lossless medium theta n is equal to 0. So when theta n is equal to 0, then what will be E bar? E bar will be Ex cos of omega t minus z ax cap. Okay, cos of omega t minus z ax cap, similarly plus Ey into sin of omega t minus z into ay cap. Okay, so when wave is traveling along plus xz direction. So wave is traveling along plus z direction. So when wave is traveling along plus z direction, so what is the formula for eta? So eta is Ex by Hy, or it is minus Ey by Hx. Ey by Hx. So this already I have explained you in the concept of wave impedance. Okay, intrinsic impedance or wave impedance concept. So I have explained you clearly how to write the formula for eta for different directions of wave propagation. So when wave is traveling along plus z direction, these are the formulas. So what is Ex value? Ex is equal to eta into Hy. Eta into Hy. Eta value is 60 pi into Hy value is 0.5. So it will be 30 pi. Okay, so 30 pi. Right. So next is Ey. Ey is eta into Ey is eta in minus eta. Minus eta into Hx. So from this equation, so Ey is equal to, send this Hx this side, so eta into Hx, so minus symbol is also there, so minus eta into Hx. So Ey is equal to minus eta into Hx. Minus eta is 60 pi into Hx is minus 0.1, so it will be 6 pi. Okay, so it will be 6 into pi. Okay, so what is the value of theta n in the case of lossless medium? Right, so in the case of lossless medium, its value is 0 only, right? See, lossless medium theta n is equal to 0. Then what will be E bar? E bar is equal to, okay, so when so is this right? So when wave here E is Ax, so we have to write here Ey, sorry. So here it will be Ey, and this here it will be Ex. Okay, so Ey value is 6 pi. 6 pi into cos of omega t minus z Ax cap plus Ex value is 30 pi. So 30 pi into sine of omega t minus z into Ay cap, volt per meter. So this is the equation for electric field intensity. Understood? So if you have if you consider Hx here, so when the wave is propagating along x direction, for this component I am talking about the first component, when wave is traveling along x-axis, then you have to take the x component in y-axis. So Ex component you have to take along y direction. Okay, so at first I have written wrong, so you have to take along x direction. Similarly, if you take here Hy, if you consider this as Hy, which is traveling along y-axis, then Ey travels along x-axis. So Ey travels along x-axis. Okay, so this is how we have to take. If you are given with both directions, if you are given with both directions of H bar, and if you want to write the both directions of E bar, you have to take in reverse order. Okay, so please keep this in mind, right? And you are asked to find epsilon r also. So what is the eta formula for lossless medium? For lossless medium, right, for lossless medium, what is eta value? Eta is 120 pi into root of mu r by epsilon r. Right, so eta is given by 60 pi, so 60 pi, so send this 120 pi also this side, so it will be divided by 120 pi is equal to root of mu r value is 1, so epsilon r value we have to find, right? So pi, so it will be 1 by 2, so squaring on both sides, it will be 1 by 4 is equal to 1 by epsilon r, so epsilon r value is 4. Okay, so epsilon r value is 4. Right, so this is how we can find the wave equation. So the important concept is how to use the intrinsic impedance formula like this, right? So by using intrinsic impedance formula, we have to find the components Ex and Ey by using this formula when wave is propagating in plus z direction. And second important thing is, if for the first component, if h bar is propagating along x, so Hx is propagating along x, then you have to take Ex in y direction, Hx in x direction, then Ex in y direction. Okay, similarly Hy in y direction, so Ey in the x direction. Okay, because both are normal to each other. Both are normal to each other. Okay. So next we'll see one more problem, the last problem for this video. Okay, so he has given that the medium is good conducting medium with electric field intensity, right, and epsilon r is 1, mu r 20, and conductivity also given for you, and he has asked to find the h bar. Okay, so medium is good conducting medium. So when medium is good conductor, then what is the value of theta n? Theta n, I have solved it and have shown that theta n value is 45 degrees. Theta n value is 45 degrees. Okay, also when the medium is good conductor, then what is the value of eta? Eta formula is omega mu by sigma. Omega mu by sigma. So all these you have to remember, right? So as I have told you, each and every property, each and every characteristics for each and every type of medium you have to remember. Okay, so when these are there, so and if E bar is something E naught into e power minus alpha z, so sine of omega t minus beta z, ay cap is given for you for volt per meter. So what will be h bar then? So h bar is E naught by eta, E naught by eta e power minus alpha z into sine of omega t minus beta z minus theta n a z cap, sorry a, so wave is propagating along plus z direction, so this will be ax cap ampere per meter. Okay, so in order to write this, we have already got the value of theta n as 45, so only thing which we require is eta. So if we will first find eta value, so eta is equal to root of omega value. Omega value is 10 to the power of 8 sine of omega t, in the standard form sine of omega t, so omega value is 10 to the power of 8, and mu naught is, so mu naught into mu r, so 4 pi into 10 to the power of minus 7 into mu r value is 20 divided by sigma, so it will be 3. Okay, so if you solve this, you will get around 28.94. So eta is equal to 28.94 ohms. So therefore h bar is equal to E naught. E naught value is 2. Okay, so 2 divided by 28.94. 28.94. And when wave is traveling along, sorry, one more thing, when wave is traveling along plus z direction, so what is the formula for eta? Eta is equal to ex by hy, so is equal to minus ey by hx. Okay, so we need in the direction of x, so we need here the value of hx. So what will be the value of hx? Hx is equal to minus ey by eta. Hx is equal to minus ey by eta. It is not only ey, so it will be minus ey by eta. Ey value is this, right? So because wave is propagating along y, so this will be the value of ey. So this will be the value of ey. So minus ey, so minus 2 by 28.94 ey by eta. Understood? So this will be minus 2 by 28.94. hx value is this, so same hx value I am substituting here into e power minus alpha z into sine of, right, omega, sorry, omega value is 10 to the power of 8 t minus beta z minus theta n value is 45 minus 45 ax cap ampere per meter. Okay, so this is how we can represent the h bar. Okay, so the important point here is theta, and remembrance of this value is important. Okay, so in the option he may give you directly, so in the option he may give all the same in sine 10 to the power of 80 minus beta z he may give. So you may keep this as answer. Okay, until and unless you remember that theta n is also present for good conductor. So theta n, that is eta. Okay, so in this case, in the case of good conductor, E bar leads H bar by 45 degrees. This is the important point which you have to remember for the good conductor case. So when you remember this point, so you'll also keep this minus 45 degrees. Okay.